An example of this is going to look like this. D over dx, a to the power of x squared. Not a. Let's say this. You can call it a as well. It's just going to be 1a. But let's put some numbers in it. So 2 to the power of x squared, the derivative is going to be itself times ln of 2 times the derivative of the exponent. What's the derivative of x squared?
2x.
2x, like that. And you're done. So this is when the base is not an e. It's any number except the natural number e. It's not terribly difficult. There's just one extra component, which is the ln of the base component. So using that rule, what's the answer to A? Yeah, this is the rule, right? So if your y is a to the power of fx, your y prime would be the exact same thing times the ln of the base times f prime of x times the derivative of the exponent. Using that rule, what's the answer to A?
It's itself
Yeah?
times ln of 8.
hmm And then there's a third component because now you have a linear function up there, so you have to take the derivative of that.
Then it's 2.
2, yes. Can we multiply these into ln 16? The answer is no, you can't. Can we multiply these into 8 to the power of, not 8, so that becomes a 16 to the power of 2x plus 5. What about this?
No.
No. So that's as far as you can go here, okay?
Mm-hmm.
For C, you just have to use a product rule. It's not that bad either. So this is your F, this is your G. And again, product rule says F prime G plus F G prime. We have to use a product rule here because the quadratic and the exponential function, they're being multiplied. So when this happens, use the product rule. So what will be the derivative here?
2x
Yeah,
times g.
and then so F as it is, so x squared. What's G prime here? It's just gonna be itself, right?
Mm-hmm.
And then ln of 2, the chain rule component doesn't apply because you only have an x here. The derivative of x, if you really want, you can put a 1 here, but that's pointless. Only do that if there is another function up top, except x. That's the only exception. If there's an x, you don't have to do anything. Okay, what about E? What's Q prime of x here? Is this a product rule question?
It's not.
It is not a product rule question. So what's the answer? So again,
Itself
itself, yeah, times what?
ln of 1.9.
Right. You know what ln is? What does ln mean? We've been using it, but what is it actually? Ln is called the natural log. This is the full form of it. Log of x means the base there is base 10. What this is, it's the inverse function of 10 to the power of x. Let's say you have this. An inverse function is something that's reflected along y equals to x. So So log of x is this function that looks like this. This is log of x. Ln of x is the inverse of e power x. You can also rewrite this as log of base ex. We don't do this, but this is what it actually means. It is the inverse of e power x. And again, it's an exponential function, so it's always going to look like this. It's going to go through the y-intercept of 1, which means the inverse function, when you reflect it on this 45-degree line, y equals to x, the angle here is going to be 45. That's not super important because this is, when you think about it, you have points 1, 1, 2, 2, 3, 3. When you draw a triangle, you'll see that it's an isosceles triangle. Isosceles triangles, the angle there is 45. Not always, but here it's going to be exactly 45 because when you take the opposite over the adjacent, these two are the same. So you'll get tan theta is 1 and tan of 45 is 1. That's why we call this the 45-degree line. Usually we just say y equals to x, if I'm being honest, but it depends on the textbook you're using. Some call it the 45-degree reference line, which just means y equals to x. And the 45 degrees comes from the fact that for this isosceles triangle, tan 45 would give you 1. So the angle there is 45. So anyways, back to the point, ln of x, the function, is the inverse of e power x. It looks like this. Since this went through the y-intercept of 1, this has to go through the x-intercept of 1. This will never cross the x-axis. This will never cross the y-axis. So there's asymptotes here. Cool.
Mm-hmm.
So that's just a brief recap. So ln of x just means log base e of x. We don't write it like that. We just call it ln. It's easier. But if you wanted to, I don't think anyone would complain. Um, so that's this in the bag. X becomes a 1, so we can ignore it. What about the next component? What's the derivative of the next part? It's just like x squared.
So 1.9x to the power of zero point 0.9.
Correct. That's it. Final answer, and you're done. Anything in this form where n is any number that you can think of, it's an integer. If that is your y prime would always be n times x to the n minus 1. If you can write it in this form.
Mm-hmm.
This, you can write it in this form. Something like this, you can also write it in that form. It becomes x to the 2 out of 3, and when you take the derivative, it becomes 2 out of 3 x to the negative 1 out of 3. It's not always possible to write it. If we could, then things would be easy. Now don't confuse this with this. This is completely different. Here the variable in question is the base, whereas here the variable in question is the exponent. A to the x is not the same thing as x to the a or x to the n. Completely different functions. This is an exponential function. When you take the derivative, you have to use ln. This is a mixed, I don't know, I'm just going to come up with a nomenclature here. This is called a mixed polynomial function, which essentially means you can write it in this form, x to the power of n. Mixed because you can also write something like this in this form. I think we did some of these questions. Not going to spend too much time on it. Let's move on to something that's very important in engineering. If you take any courses in university, economics, what else? Business applications, the derivatives of sinusoidal functions. Sinusoidal means trig functions. Very simple. Once you know it, it's simple. If you don't know it, then we're going to be scratching our heads. If y is sine of x, Sine of x looks like this. It's a periodic function. It has a period of 360 degrees, just like the circle. So if you start here, comes up, down, up, right here is where it would end. Up, down, up. So that'll be 360 degrees. In radians, it's called 2 pi radians. And again, remember, radian is a measure of an angle. So sine of x looks like that. Its maximum value is 1. Its minimum value is -1. And it's going to look like this forever and ever. It never stops. It is an odd function. It's an odd function because whatever you have in quadrant 3, you have in quadrant 1. Another way to look at odd functions is that if you do f of -x, that negative sign comes out. Now the derivative of this is very simple. Y prime of sine of x, and again, you can never write this in this form or this form. So the rules we have used so far doesn't apply to these. They have their own unique rules. You must remember them. Sine x, the derivative, is cosine x. Easy peasy. Cosine x looks like this. I need some space. Very similar to sine x. Minimum is 1, maximum is -1, period is still 360. But the difference is sine x goes through the origin. 0, 0 for sine x. Cosine x doesn't go through the origin. Cosine x, you can also think of it this way. Cosine x, the function, is sine of x, the function, moved 90 degrees to the left. Remember, x plus 90 means it's x lies. So you would think this goes 90 to the right, but actually it goes 90 to the left. So if we take this curve and move everything 90 degrees to the left, so this point will come here. This point will come here. It'll end up looking like this. And this is cosine of x. Instead of going through 0, 0, the starting point is now 0, 1. The period, again, is still 360. So from here to here, any 2 points you pick, it's going to be 360 or 2 pi radians. So it's just a variation of sine x. And you can also think of sine x as a variation of cosine of x. If you move cosine 90 degrees to the right now, and if you compare these two curves, to get this out of this, you have to shift this 90 degrees to the right. So x minus 90. They're related. Because of this, because they're related, sine of 1 is the exact same thing as cosine of 89. They must add up to 90. Sine of 30 is the exact same thing as cosine of 60. These two angles, they're complementary, adds up to 90. Sine of 90 is cosine of 0. Same thing the other way around. Cosine of 0 is sine of 90. So if you have one, you automatically have the other, okay?
Mhm.
So the derivative of sine of x is cosine of x, and the derivative of cosine of x is a little bit more annoying. It's sine of x, except there's a minus sign in the front. It doesn't apply to the other one. It's only for this one. Cool?
Mhm.
So if y is sine of f of x, so let's say sine has a function inside of it, sine of x squared. Y prime will be cosine, again, the bigger picture. Sine is the outer function. This takes priority. This is going to be your bigger picture. It's going to be cosine of f of x, but then you need to multiply this with the derivative of the bracket. So as an example, if this is your y prime, the derivative of sine is cosine. The angle stays the same, but then you have to take the derivative of this. So you multiply this with 2x. And that is not equivalent to cosine of 2x cubed. Okay? You cannot multiply this and this. This is the angle. It belongs with the cosine. So there is an invisible bracket here. We don't put it, but it's implied. It's inferred. You cannot multiply this with the angle. This is a
Mhm.
function. This is the inner angle. So that would be the final answer for that question. That's it, right? That's it. Let's see how hard could this possibly get? You just have to remember the chain rule component. So if there's an inner function, you have to multiply it with the derivative at the end. All right, so what's the answer to A? What's y prime? The rules are up there if you want them.
It's negative sign.
It's negative sign of what? What's the angle? The angle doesn't change, okay? The angle doesn't change. Like that.
Mm-hmm.
And then what?
3.
3, done. You could move that 3 in the front if you like. This is fine. But you cannot multiply that 3 with the angle. For B, what's y prime? Now here, you know what to do. You have two different functions. You have to use a product rule. No? It's not as hard as you think. You just need to know the product rule, right? This is F, this is G, F prime G plus F G prime. What's F prime? What's the derivative of X? Uno, right? Because it's 1x. The X disappears, so
Mm-hmm.
it's just a 1 times sine X as it is, plus X as it is, F as it is, times what? What's G prime here?
Cosine X.
Cosine X. Done. Cool?
Mm-hmm.
That's it, man. That's all there is to this. They will make it complicated, right? Here's a complicated problem. Sine of cosine of x cubed. Let's look at this one. Let's say this is y. Remember, sine becomes cosine, and cosine becomes negative sine. Let's look at this. Now, so far, everything we've done had two things. It had two levels. Here we have three levels. What I mean by that is this is the outer function. This is chain rule component 1, cosine function. And this x cubed is chain rule component 2. So look at how I do this. Y prime always start from the outside, okay? The outer function takes priority when you're doing derivatives. Later on, you'll see integrals, which is the antiderivatives. Sine becomes cosine. This is the angle for sine. Angle doesn't change. So now we've dealt with the outer part. Now let's go one level deeper. The next part is cosine of x cubed. The derivative of cosine of x cubed is going to be negative sine of x cubed. Now this is the second level done. And then we go to the final level. X cubed, what's the derivative of x cubed?
It's 2x squared. I mean
3x.
3x squared.
3x. And there you go. That's the final answer. It looks very wonky, but that's all. Cool?
Yeah.
Yeah, this one might throw you off. There's a difference between these two. I'll tell you what the difference is, okay? So there are some invisible brackets here. Sine of x squared means sine of x squared, like this. Whereas sine squared of x means sine x whole squared. These are equivalent. So you need to know this, otherwise you're going to make a mistake. And the answers here will be different. Let's try it. What's y prime? For sine of, in a bracket, x squared. The angle here is x squared, whereas in the other one, the angle's x.
It's cosine of x squared
Yeah? Anything else?
times 2x.
Times 2x, perfect. Okay, what about the other one? What's y prime here for b?
Do you bring the 2 down?
Yes. So it'll be 2 sine of x, right? The outer function always takes priority. So here the outer function is x squared or squared function. What do we multiply this by?
By cosine of x.
By cosine of x. And we're done. Cool? That's it.
Mm-hmm.
Okay, here's another one. It's just a two-parter because you just have to use the chain rule once. It's honestly not that difficult. You can do this in 10 seconds if you know the rule. What's y prime?
It's negative sine.
Yeah? Angle doesn't change?
Mm-hmm.
Angle will never change. Times what?
Times 3x squared.
Done. Easy peasy, one-step answer. Hmm. Let's look at this one. Again, it looks tricky. It's just one step. Now the function, okay, now be careful here. The function is e power x. What's the derivative of this?
Itself.
Yeah, and then?
And then it's cosine of x.
So times cosine of x, that's correct. Anything else?
Plus negative sine of x.
Yes. So now plus negative sign just means minus sign. And done. One step. Now remember what equation of the tangent is. So this function, x cosine 2x, no idea what that looks like. Let's actually graph it. X cosine of 2x should still be an odd function. Yeah, it's still an odd function. What's the x value? Pi over 2. So let's go here. I'm going to show you how to do this. Uh, Oop, where did my thingamajig go? I don't want to save. I'm trying to change the axis so it makes more sense for us. To change my axis, I need the pi, which is here, so I should not have deleted that. So we are going to copy this. I think I could have typed pi here. So what's important here is that on the x-axis, if you notice right now, you see these 2, 3, 4s?
Mm-hmm.
These labels are in radians. So it's 2 radians, 4 radians, but usually, just to make it easier, we denote radians in terms of pi's. So what I'm going to do here is I'm going to change the step for the x-axis as pi over 2. Now we have something we can work with, right? Last time it was 1 here, 2 here. That didn't really help us much, but this is something we can work with. So it's asking us to find the derivative at pi over 2. Not the derivative necessarily, but it's asking us to find the slope of the tangent line at pi over 2. Remember what tangent line means? What's a tangent line? It's a line that
Is it like
just,
the slope at a certain point?
yeah, exactly. It's just a slope at that specific point. So right now, our tangent line is just going to touch pi over 2. So pi over 2 is there. So our tangent line is going to look something like this. Not a perfect drawing, but what's important is that the angle here is going to be 90 degrees, okay?
Mm-hmm.
So if you were to draw this out, the angle between that point and this line would be 90 degrees. It's going to be perpendicular. So the question here is asking us, what is the equation of this green line here? What's the equation? What's the equation of a straight line in the general form? Straight lines are always y equals mx plus b. Sometimes it's called mx plus c, but it's not important. It's always going to be in this form. This is called the slope-intercept form. Some books, some teachers like to use this slope point form, this one's called. They're both fine. They're both equations of a straight line. This one is
Mm-hmm.
slope intercept, the y-intercept, whereas this one is slope point. So you need an x1, y1. I'm gonna stick with mx plus b because less cluttered. So what two variables are we looking for? If you look at that equation, what two things are we missing? Y and x will never change, right? In a straight line, it always has to be there. So we're looking for m and we're looking for b,
B.
right? One of them is easier than the other. B is way easy. Let's just get B over with. If you look at this straight green line, and if you look at that red line, what do they share? They share this point, right? They're touching at
Mm-hmm.
one specific point. So that point is common for the green line as well as the red line. Actually, we can't find B just yet, but that concept is still true. To find B, we need M. So let's first find M. So M is called the slope of the tangent line. And it's very simple. M is just y prime at a certain x value. So here, it'll be y prime at whatever the x value. The x value will always be given to you. So it'll be y prime at pi over 2. So here are the steps. Number 1, you find y prime. Number 2, you plug pi over 2 into y prime, and that'll give you the slope. That'll give you the m value. Step 3, you're going to plug y and x. Do we have the y value? We don't have the y value. You're going to first find the y value by plugging the x value into the main equation. This will give you the y value. And now you have your x value was always given. You just found your y value. And this will give you the slope. You also have the slope. You're going to plug all three into this. I messed up the letter. It's not B, it's M. You have the slope, and you're going to plug all three of them back into this equation, y, m, and x, and that'll
To
give you
find B.
b. So that's the step, okay? It's not terribly
Mm-hmm.
difficult. So let's go one by one. Step number 1, we're going to find y prime. Step number 2, we're going to plug pi over 2 into y prime. So if you look at this equation, what's y prime?
Like of pi over 2.
No, so of y.
Oh,
Pi over 2 would be 0 because pi over 2 is a number. The derivative of a number would be 0. We need to find y prime of y. So what's the derivative of y here?
it's negative sign of
Good try, but no, that's wrong. What'd you mess up? Product rule, because you have x times cosine of 2x, right? So
Oh,
the negative sign doesn't apply until after the plus sign. So this is f, this
so
is
1
g.
plus.
No, not 1 plus. So remember, it's f prime g plus f g prime. So it'll be 1 times cosine of 2x, right? Look at this. F
Mm-hmm.
prime is 1, and then g as it is. Cosine 2x plus what? What's the
X.
x times what?
Negative sign.
negative sine of
of 2x
2x. Anything else?
times 2.
Times 2, exactly. So this gives you, I'm just going to clean it up, cosine of 2x minus 2x sine of 2x, like that. So this is y prime, okay?
Mm-hmm.
Now we're going to plug pi over 2 in here, here, and here. I'm going to do this in a calculator. If they ever give you pies, x values in terms of pies, you have to put your calculator in radian mode. So in all calculators, there's a button called DRG, degrees, radians, gradients. This is a French thing. We never use G. Degrees we use, I guess, time to time, but in high level math, we always use radians. So if they give you pi, if you see pi, know that your calculator has to be in the R mode. So I'm going to put mine in the radians mode by pressing Shift and the DRG button. So I'm in degrees, I am now in radians. So I'm going to plug here, here, and here, pi over 2 on the calculator. So cosine of 2 times pi over 2 minus 2 times pi over 2 times sine of 2 times pi over 2. Does that look like a zero slope here? What do you think the slope? What are we
No.
expecting? We're expecting the slope to be negative, right? I got exactly -1. So our slope is -1. So that's step number 1. Step number 2, we have m, that's your m value. To find b, we need both m, x, and y. Not y prime, but y. Now, how do you find y? You just plug pi over 2 into the main equation. This is the y value that both the red function and the green function share. So you want to do y of pi over 2, like this, okay?
Mm-hmm.
So this will give you pi over 2 times cosine of 2 times pi over 2. Again, you can plug this in a calculator. Eventually, you don't have to because these are standard form things. So the answer here is negative pi over 2. And now we plug everything in to find the b value. We don't even need this. So so this was our equation, y equals mx plus b. This y is the same thing as this because they share the same y value and the same x value at that point. That is negative pi over 2 equals to, that slope m value is -1. That x value is pi over 2 plus b. So this becomes negative pi over 2 plus pi over 2 equals b. So b is 0. It just means it goes through the origin. So final answer, y equals -1x. Again, remember, it has to be in this form. So m is -1 plus 0, or you can ignore the 0. So that'll be the final answer for this question.
Mm-hmm.
Did that make sense?
Yeah, it did.
So equation of the tangent line, same process. You're going to find y prime at that x value. You're going to find the y value at that x value. This is your m. This is your y. And x value will always be given. And then you're going to plug all three of them into y equals mx plus b. That's it. That works for any function.
Mm-hmm.
So minus x, I think that's what we have, -1x plus 0 or whatever. Not going to bother with this extreme value because it asks us to make a table. Let's focus on derivatives. Let's do some of these. Could be interesting. I mean, they're all one step. If you know it, you know it. All right. For f, what's y prime? What's the derivative of 2 power x?
The
itself.
itself. Mm-hmm.
Yeah, and then what else?
Ln of 2.
Ln of 2, and that's done. There's no chain rule component. Plus, what about the next term?
2 cosine.
Perfect. What's the last component?
2 negative sine of x.
So minus 2 negative sine of x, and you can bring this minus sign here to make this positive, okay?
Mm-hmm.
And that's it. Done. Okay, G. What's y prime?
It's cosine of e to the x.
Yeah? Anything else?
And then itself, like times e to the x.
Yeah, done. Okay, what about H?
um 3 cosine of the bracket
Times.
times 3.
Okay, what about the 2 pi?
Doesn't that just go away?
Yes, because it's a constant, right?
Mm-hmm.
Goes away. See you later. Okay, I. It's a tricky one.
2x
Yes,
sine x.
minus sine x or plus negative sine x. What about the last one? Be careful, it's a trick one.
Um,
And the question you want to ask yourself is this a function or is this a constant? Here's I'll make this easier. So let's look at this one. Say you had x squared, pi over 4 squared. So you had e to the x, e to the power of pi over 4. And the question is, are these constants or are they functions? Because pi over 4 is a constant, okay? Pi
mhm.
over 4 is whatever, 3.14 divided by 4. These are all constants. They are not functions. The derivative of a constant is a 0. So here, plus 0, or you can ignore the plus 0. Cool?
Okay. Mm-hmm.
It's the same thing as saying e to the power of pi over 4. This is not a function. The derivative of this would be a 0.
Mm-hmm.
Simply a constant. Pi over 4 squared, derivative would be a 0. Same concept here. They trick you sometimes like this. The last one is most definitely a function, and it's a little bit tricky as well. What's the answer to J?
So cosine of 1 over
Yeah? What do we multiply this?
negative x to the power of negative 2.
And that's perfect, yeah. Because that's the same thing as x to the negative 1, so you have negative 1 x to the negative 2 done. That's it. Are these difficult?
No.
Not really, right? Um, let's try these guys. Might be more of a challenge. Now remember, sine squared. This squared applies to the entire function. Does not apply to the angle. You know what I mean? This is
Mm-hmm.
equivalent of sine of square root t. This entire thing squared is what that's equivalent to. So what'll be v prime of t here? What'll be the derivative?
So you bring the 2 down
Correct?
and then cosine.
No, not yet, because now 2 is on the outside. The squared function is your bigger picture. That's going to take priority. Everything inside will be the same. It's like saying this, x squared plus 3 squared, right?
Mm-hmm.
Inside is going to stay the same for now. Same idea here. The inside will stay the same for now. And then you multiply this with the derivative of the bracket. So what's the derivative of the inside part? Remember, the angle doesn't change. So essentially, what's the derivative of sine?
It's cosine of
Cosine?
root t.
Root t, but now you have to go a level deeper because you have a square root function inside. You have to multiply this by the derivative of this inner function. What's the derivative of root t?
It's 1 over 2t.
Does it have an exponent? So let's look at this. Root t is equivalent to t to the 1 over 2, right?
So to the power of negative 1 over
Yeah, to
2.
the power of negative 1 over 2. There you go. And that's the final answer here. It's a three-parter
Mm-hmm.
because there's three functions. There's a squared function, there's a sine function, there's a square root function. The number of chain rules, again, this is something that I'm coming up with it on the spot, is always going to be the number of functions minus 1. So here we had to use the chain rule twice because there are three functions. The next one is annoyingly difficult. It's not difficult, it's just tedious. All right, so now we have a three-parter here. What's the rule we use?
The product rule.
The product rule. So, usually we have two functions, but here we have three functions. Does it change anything? Changes nothing. So you can either pair the first two, call that f, or you could pair the second and third, call that g. The answer, final answer will be the same. So I'm going to go this route. Before getting into the product rule, I'm first going to find these guys individually. What's f prime here? If this times this is f, what's f prime?
Cosine of x.
Yeah?
And then cosine.
Nope. So now you got to think of it. This is your f, right? This is a product rule within a product rule. So if we were just looking at the
Mm-hmm.
bigger f, we have f, and the formula is f prime g plus f g prime. Remember, don't forget the g. So it'll be cosine for this sine times g as it is plus sine as it is times g prime, which will be 2 times cosine of 2x. Yeah?
Could you do that one more time?
Yes. So maybe I'm going to call these something else. So we have f times g, okay? Let's
Mm-hmm.
call it something else. What comes after g? Let's call it h and k. So inside of f, we have h and we have k, right?
Mm-hmm.
Product rule is f prime g plus f g prime. In other words, it's h prime k plus h k prime. Why don't you try it? Tell me what's f prime. You're going to be using this.
So it's cosine of x
Uh-huh. Times
times sine.
sine of 2x, yeah.
Mm-hmm.
Plus,
And plus sine of x
yes. Times,
cosine of 2x
yes. Chain rule,
times 2.
times 2. That 2, I'm going to bring it forward. There you go. So that's f prime.
Mm-hmm.
Now let's look at g prime. G prime is going to be what? So it's just one function, right? Not that difficult. It's going to be cosine of
Of
3x times
3x.
3.
Mm-hmm.
So we have f prime g prime. Now I'm going to find the final answer. So h prime of x, the derivative, I'm going to be using this formula here, is going to be f prime g. So it'll be this entire thing, cosine x times sine 2x plus 2 sine x times cosine 2x. That's f prime times g as it is. So times sine of 3x plus f as it is. So original f was sine x times sine 2x, right?
Mm-hmm.
Times g prime, which is 3 cosine 3x. There we go. And that's the final answer. So anytime you have a three-parter, sometimes you may even have a four-parter. I would recommend that you first split it up. Actually, that's the only way to do it. You have to split it up first, and then you write down their derivatives here first before using the product rule. Otherwise, it's going to get too convoluted. Okay?
Mm-hmm.
If you try to
Yeah.
do this like this in one step, then it's going to get mixed up, especially in the beginning. Maybe after a few months, after you're comfortable with it, you can go here. But I would highly recommend you do it like this in the beginning. And we will see, I don't know actually, I don't know if we'll see a four-parter. There can even be five-parter. You'll definitely see it in university, but here we don't have any four-parters, but it's pretty common. All right, let's call it there for today.
Okay. Thank you.
See ya.